Hello, my name is Helen Hasty from Heriot-Watt University, and today I'm going to be talking about trustworthy social robots. So the talk outline is, first of all, I will give an introduction to trust and why it's important for social robotics. Then I'll talk about 3 research projects that are ongoing at Heriot-Watt to do with social robotics. And then I'll delve into 2 studies, one for remote monitoring of autonomous systems and the other for a triage robot. Both involve trust and social robotics. And then finally, I will talk about the National Robotarium and our future projects that will involve the Furhat robot. So trustworthy social robotics is going to be very important going forward, but what is trust? So trust is a very complex, multifaceted concept. Trust between humans and humans is not very well understood, let alone how trust would form between humans and robots. And there are lots of definitions of trust out there. So I will take Rousseau and Mayer's definitions combined. So Rousseau talks about trust being about being vulnerable to the other person's actions. And Mayer adds that this may be irrespective of the ability to monitor or control the other party. And this is relevant for robotics and autonomous systems. As they become more autonomous and are able to reason and make their own decisions, we may have to trust them irrespective of the ability to monitor them or even understand the reasoning behind their decisions. So what about human and robot trust? So trust is an attitude that an agent will perform as expected, so a bit like the human-robot trust, and that the agent can be relied upon to reach its goal. And trust can generally be quickly gained, so there's something called the automation bias, where people are generally initially trusting of automation and robotics, but trust can be quickly lost. So trust breaks down when there is a mismatch of representations between parties. This could be, for example, a misunderstanding of the task or the context or the world surroundings. So there is a need for a shared mutual understanding of the task and the surroundings. And trust calibration will be key because these relationships will form in dynamic, uncontrolled scenarios. And so there's a need to be able to adapt and maintain the appropriate amount of trust, so not over-trusting and not under-trusting. So Hancock et al. Came up with a meta-analysis, first of all in 2011 and recently updated, and they discussed in the first meta-analysis 3 different factors. So the human factor, such as one's own propensity to trust in general, and then of course robot factors, social cues, personality and reliability, and then finally environmental and team, so this is the task and the context. So it's quite interesting to think about these various factors that can all influence human-robot trust. So we've been fortunate to have been awarded significant funding to look at this idea of human-robot trust. So this is a project called the UKRI Trustworthy Autonomous Systems Node on Trust. It's part of a larger TAS UK-wide program. This is one of the largest programs internationally that is looking at the idea of trustworthy autonomous systems. And there's various different nodes all looking at different things such as verification and security. But our node, the aim of our node is to look at human-robot interaction and how we can develop methods to gain, maintain and manage trust through interaction in dynamic environments. And this is a project with Heriot-Watt, Imperial College London and Manchester, and it's very much a multidisciplinary project. So we have Professor Tusha Rajendram from psychology at Heriot-Watt, Angelo Cangalosi from Manchester, who's cognitive science and psychology, and then Yanis Demiris from Imperial College London, who's in robotics, machine learning, engineering. So we're very excited to be starting this project, and there's a website there if you are interested in getting some more information. The key research questions on the node are, can we create a cognitive architecture for trust that models a variety of trust factors, including theory of mind? And I'll talk a bit about that in a minute. Secondly, can we define a set of principles of how trust is acquired over time and how it can be adapted to context, areas, the environment, and various users? So can we create these adaptive systems, including adaptive principles for transparent interaction and explainability? And then finally, can we create an evaluation framework for reliably measuring trust in a non-obtrusive manner? We don't want to have to stop an interaction and give somebody a subjective questionnaire to try and gauge their levels of trust at that point in time. So if we can find ways where we can automatically predict a user's trust, that would be very, very interesting. And can we do this across multiple different domains? How does this change with different tasks? So the three kind of pillars of work are modeling, so cognitive models of trust, and then adapting to tasks and users, and then finally validating across a number of different industry relevant applications. So going back to theory of mind. So theory of mind has been intrinsically linked to trust. It's the ability to infer another's beliefs, desires, and intentions. Sometimes it's a bit like mind reading, although, of course, we can't literally read each other's minds. We can try and make sense of what's going on in people's minds based on their behavior. And mistrusts can happen when there's a mix-up between how two people understand a situation. So humans are quite good at resolving this through having a conversation, saying what they really mean, or asking probing questions until we reach a mutual understanding. So the challenge for us in trusting robots and being trusted by robots is to find a way to make the perspective of the human and the robot transparent to each other. And on our Node project, we're going to look at doing that through a variety of techniques, including human-robot interaction. Second project I want to mention, because it relates to a study that I'm going to talk about later on, is the EPSRC Orca Hub. So the aim of this, it is quite a domain-specific project. So what we're looking at is offshore platforms, so for example, offshore wind farms, and how we can support a long-term vision of this industry for completely autonomous offshore energy fields. So that way we can keep human operators safe from hazardous environments by keeping them onshore and having the robots offshore, doing, for example, inspection and maintenance. So there are a number of different aspects of the project that I won't go into, but please visit the website for more information. But what I'm interested in is the human-robot interaction part, which is the work package that I'm involved in. And what we've been working on the last few years are in our personal assistants, our interactive, that can be used for maintaining situation awareness, managing trust, and encouraging adoption of these remote autonomous systems. So typically robots that are out of line of sight or that are remote are trusted less than those that are in close proximity to the users. So we are looking at ways through these kind of intelligent personal assistants that we can reassure the user that these autonomous systems are behaving as they are supposed to. And that's a large investment with five other institutions listed on the slide. Now, the third project I wanted to mention at Heriot-Watt is the Horizon 2020 Spring project. And this involves Oliver Lemon and Christian Dundrop from the Interaction Lab. So there's a point of contact there if you have any further questions about this project. And the main aim is to develop social robots for elder care. And this is based around the Alana conversational AI system. And there's a spin out, alanaai.com. And building on Alana to add multimodal conversation, visual language grounding, and multi-person conversation so that we can interact in a socially appropriate manner with the elderly. And there's 5 different partners. Importantly, we've put Alana on a fur hat. I'm afraid I don't have a video right now, but we are looking at putting Alana conversational AI on the fur hat to give it the added social dimension. So that's 3 projects that we've been looking at. So let's go back to the Orca Hub and the fur hat. So we did a study where we developed, it was a wizarded system where we had a fur hat robot as a personal assistant. So the research question that we were looking at, these digital assistants such as Alexa Home or such as Amazon Alexa or Google Home, we see them in a domestic context. What happens if we pick them up and move them into the workplace? And how do they manage trust in the workplace? So we picked a high stakes emergency response scenario so that we could hopefully emulate this idea of vulnerability that I talked about earlier, so that hopefully we could observe varying levels of trust. So the research question was, does embodiment affect trust and performance in a workplace context? So we compared, in a within subjects experiment, we compared the Furhat robot versus a smart speaker with the same voice. And of course, the social robot was able to exhibit social cues such as mutual and shared gaze, and we varied the emotional expressions of the Furhat using its back projection face. This is currently under review in a journal. So I will just give you some brief headlines. Before I do, I'll just play a bit of the interaction so you can get an idea of how the Furhat is helping the operator in this kind of scenario.
Hi, my name is Fred and I'm your emergency assistant. Emergency alarm went off in North Tower Christmas trees. We have 4 minutes and 11 seconds to avoid evacuation. Do you want to make a PA announcement to evacuate the area?
Yes.
Okay, action performed. What type of robot do you want to use to perform the inspection?
A drone.
Okay, sorry, can you tell me which robot do you mean?
A drone.
Let me check that for you. Quadcopter 1 is available.
Good. Okay, send it.
Sending the robot to the designated area.
So here you can see, for example, the robot exhibiting shared attention, looking at the screen. So our initial findings was that there was a general preference towards the robot over the speaker, and that more trust was expressed towards the robot when contrasted with the smart speaker. So when we asked them to compare the two, they said they trusted the robot more, and furthermore there was higher task engagement and faster decision making with a robot over the smart speaker. Another study that I will briefly touch on is this idea about transparent interaction and trust. So as autonomy becomes more complex and we use methods such as deep machine learning, it's going to be very difficult for us to clearly convey the reasoning behind the decisions. So one way to do that is through natural language explanations, which is an area that I'm very interested in. So in this experiment, we had a robot who was doing COVID triage. So the subject would come in and would answer some questions, and then the robot would decide whether to send it home or to follow it to another room in the hospital. And we looked at high versus low transparency and also robot error versus no error. And very briefly, our findings was that there was a significantly higher trust between participants and the robot if the robot was more transparent, but only in the condition when it was behaving appropriately, i.e. no error. And then participants were also more likely to make better decisions when the transparency was high, i.e. ask for a second opinion. And that was clear when no error occurred. So the idea of providing explanations and transparency is going to be very important, and how we can use social cues to, for example, express the levels of certainty of our reasoning, of our explanations. I think that's a very interesting area going forward. So some exciting news is that we are now building a national Robotarium on the outskirts of Edinburgh, on the Heriot Watt campus, and this will be opening in spring 2022, and it will include 6 HRI labs along with other world-leading facilities. And it builds on our work at the Edinburgh Centre of Robotics, which was founded in 2014 and has received large amounts of income for research since then, so it's a large body of work in robotics and autonomous systems. And what we're looking at here is more than just a building, but what the ethos of the National Robotarium is, to really bring industry and research together so that we can co-create solutions for challenges that industry is facing, so that we can more rapidly get our research and our robotics out into the marketplace. And so it's a joint initiative between Heriot Watt and Edinburgh University, and it's funded through the Data-Driven Innovation Programme. So I'm just going to very briefly play this video on the National Robotarium. And the reason I'm doing this is because we're just purchasing a Furhat to go in the reception area, and we've also been working on a prototype for a robot cafe that will also hopefully be situated in the National Robotarium. And we're currently working on a system for the Furhat robot to welcome and register visitors. So there's the Furhat robot. So future research includes looking at this Furhat as a social robot and looking at trust and various aspects of interaction. These include voice, gender, personality, accent, naturalness, embodiment, social cues, facial expressions, and importantly, interaction strategies and transparency, all varying the task and context. Also important is automatically predicting the user's level of trust from the interaction and establishing their propensity to trust, and therefore adapting interaction based on those, both real-time trust and also the general propensity of the user. And importantly, we want to be able to test and evaluate in the wild. And that's why we're working on the robot receptionist and barista and working closely with industry. So in conclusion, human-human trust is formed through social interaction. And so this idea of social interaction is going to be very important for humans and robots if they're to develop any kind of trusting relationships. And we're going to be looking at social cues combined with other interaction techniques such as language, explanations, and transparency. And then, as I mentioned, we want to install the robot in the National Robotarium and run experiments in the wild. And the final point is to thank the Furhat team for all their support over the last years. We've been using Furhat for a number of projects as well as student projects, and we've had a lot of success and a lot of fun using the robot. So thank you.